All right, today we're going to talk about the law of conservation of matter and everything that means for us when we're dealing with matter and atoms and molecules and chemical changes and chemical reactions and the equations that show those chemical reactions. First off, the law of conservation of matter states matter cannot be created or destroyed. Matter is simply rearranged through chemical reactions, which means we don't lose matter, it only changes form. The same amount of matter in the universe now is the same amount of matter that has always been in the universe. We have not lost it, we have not created it, we cannot lose or create matter. It is what it is, just rearranged in chemical reactions. So, those chemical reactions, we look at chemical reactions in terms of chemical equations. So, with the law of conservation of matter in mind, in a reaction we have the same number of atoms that goes into a reaction, those are the reactants, must also come out of the reaction. Those are the products. So we have to have the same number of atoms that go in that come out, because once again, matter is not created or destroyed, it is only changed forms through chemical reactions. So here is the rust reaction. Iron and oxygen get us iron oxide. The same number of atoms going in is the same number of atoms going out. So you can see in the reactants portion, there is iron and there is oxygen. Okay, the coefficient, that's the number in front of the big number here. The coefficient tells us there are 4 single iron atoms going in. 4 total iron atoms. Okay, the coefficient in front of O2, which is oxygen gas, means there are 3 molecules of oxygen gas going in. Okay, the subscript tells us that there are 2 oxygen atoms for every oxygen molecule. So if there's 3 oxygen molecules and each molecule has 2 atoms of oxygen, then there's a total of 6 total oxygen atoms. This subscript tells us there's 2 oxygens for every oxygen molecule. This coefficient of 3 tells us that there are 3 total molecules. 2 times 3 gives us 6. Okay? You cannot confuse coefficients with subscripts when we're working with equations. Okay? When you're balancing an equation, to make sure that you haven't broken physics or chemistry, you haven't created or destroyed any matter. Okay? Coefficients are placed in front of the atom or molecule or compound to tell you how many of the entire thing there are. Okay, and when you have when you have a coefficient and you have a subscript, okay, you can distribute just like you do in math class. Okay, when you have a coefficient as well as a subscript, you can distribute, like we saw in the iron oxide reaction that we do not see here. There's no distribution necessary here, right, because there's no subscript with your coefficient. So the coefficient tells you how many of these, in this case it's just sodium. There's no coefficient here, but there is a subscript telling you that for every chlorine molecule there are 2 chlorine atoms. Okay, subscripts are after and below, coefficients are before. So here we have 2 sodium chloride molecules because we have a coefficient of 2. So you can see in the product portion of the iron oxide equation, right, you have a single compound that's formed, iron oxide. Okay, that is Fe2O3. That is iron oxide. But we have a coefficient of 2, which means there are 2 molecules of iron oxide. Okay, so you're going to distribute that 2. So you have 2 irons. For every iron, there are 2 atoms. Therefore, you distribute 2 times 2 gives you a total of 4 iron atoms. Okay, there's a total of 2 of your O3, 2 times 3 gives you a total of 6 oxygen atoms. So you have to distribute your coefficient to each individual part of the molecule to figure out how many atoms you have, so you can know that the same amount of atoms going in is the same amount of atoms coming out. Can't lose, can't gain. Law of conservation of matter. So, you got a total of 4 irons and 6 oxygens going into the reaction. These are the reactants. And then we have a total of 4 irons, 2 times 2 here, the coefficient, times the subscript, 2 times 2. 4 irons and 6 oxygen. Once again, distribute the coefficient to the subscript. 2 times 3 gives us 6. So we had 4 iron and 6 oxygen going in, and we have 4 iron and 6 oxygen coming out. The amount of atoms in the reactants matches the amount of atoms in the products. Okay? Law of conservation of matter. So we have to balance our equations. When we're writing chemical equations, we have to balance them in order to not violate this law, which we can't do because it's physically impossible, but so that we are accurate in our equations, we have to balance them. Okay, so we're going to talk about several different kinds of chemical reactions. There are 4 different kinds that we're going to speak of. There are more, but there are 4 kinds we're going to speak of. Synthesis, meaning to put together. Decomposition, meaning to take apart. Single replacement, and double replacement. So a synthesis reaction, like I said, it's combining things. Okay, we're going to combine 2 or more substances to form one new substance. 2 or more substances here, right, combining to form one. 2 or more here, combining to form one. Okay, so we have an element or a compound. We add another element or a compound, and we get one singular compound. Synthesis. A plus B gives us AB, for those of you who like math. A plus B gives us AB. That is synthesis. Decomposition, it's the opposite of synthesis, right? We're breaking things apart. So we take our compound and we break it into either 2 separate compounds or some elements, which is what we have here. So we take this one compound and break it into 2 pieces, 2 or more pieces, and take this compound and break it into 2 or more pieces. Okay, so we take a compound and we break it up. AB equals A plus B. Decomposition, opposite of synthesis. All right, so a single replacement reaction. Okay, we're going to switch out some elements in compounds, or switch out an element with the compound, and then we'll have an element by itself. Okay, so we're just switching places. One thing is switching places, which is why it's called a single replacement. Okay, so we have an element plus a compound, and we get an element plus a compound. Okay, A plus BC, and we're going to switch, right? We're going to switch something out. It gives you AB and C, AB by itself and C, or A by itself and BC together. Okay, you notice you've switched. Notice that we've switched. So here we have what's switching places here? A plus BC equals AB plus C. So the C and the A have switched places, right? Here you have A plus BC, right? And the A and the B have switched places. So it's a single replacement. One element changes places with another. Very simple. Okay, so not much more difficult is your double replacement. Okay, you're going to have a double switch. It's like they're trading partners. Okay, you're trading partners. So you are going to switch out positive and negative ions. Looking at these compounds, and we're going to turn those into these compounds through a chemical reaction. Notice that we have traded partners, right? You have lead and chlorine together. Then we have over here lithium, sulfur, and oxygen, right? And we are trading places. Okay, lead and lithium are trading places. So we switched partners. Switched partners. We're trading partners. Okay, AB plus CD, and then you have traded partners. Okay, A is with D, and now C is with B. It's a double replacement. We've traded partners. Pretty simple. We'll work with multiple examples of this in class. Okay, so we're balancing these equations. Once again, the most important thing you have to remember is the reactants, what goes in, must equal the products, what comes out. Reactants must equal the products. You must have the same amount of atoms of each kind going in as you have coming out. Reactants equal products, right? If we got one methane molecule, we're going to break that up. It's got 1 carbon and 4 hydrogens. Then we've got some molecules of oxygen, giving us a total of 4 oxygens. On the other side, we also have to have, that same 1 carbon has to be here. We still have to have 4 hydrogens, okay, and we still have to have a total of 4 oxygens. We got 2 there and 2 there, which means we have the same number of atoms in our reactants as we do in our products. Okay, so you can write chemical reactions in different ways. You can write a word equation, such as nitrogen monoxide. We know that that's a nitrogen and an oxygen. Oxygen added to nitrogen monoxide gives us nitrogen dioxide. Okay, gives us nitrogen dioxide. This is obviously a synthesis reaction. Okay, we've got some nitrogen monoxide, we've got some oxygen, and then we end up over here with nitrogen dioxide. The coefficients, once again, indicate how many of the molecule, and we can also indicate states of matter, right? We have gases, and then we have a gas as our product. Okay, a G equals gas, S is going to be solid, L will be liquid, and then when you have something called an aqueous solution, right, that is something that is dissolved in water. A balanced chemical equation, right? It has atoms, it has coefficients, right? And we have the same number of atoms on both sides. So here we have 4 potassium going in, and you can count the same 4 coming out over here. 2 oxygen going in, you can count the same 2 coming out over here. It has to balance. Okay? Conservation of matter, conservation of mass tells us we have to make sure it balances. We have to count each atom going in, and we have to count each atom coming out to make sure that they match. Okay, we're going to take note of how many atoms of each element go in and take note of how many come out. So, we're counting atoms. Got a carbon, 4 hydrogen, 2 oxygen, and it has to match, right? Uh-oh. It doesn't match, right? So we have to change it. We have to add coefficients in order to have. Now we got 1, 4, and 4 going in, and we have 1, 4, and 4 going out. They have to match. Okay, so we're going to balance this equation. We're going to add some hydrogen gas. We're going to add some oxygen gas, and we're going to get a product of water. Okay, so let's count. Here we go. Let's count some atoms. Reactants, hydrogens. We got 2 hydrogens going in. We have 2 hydrogens coming out. Well, that's good. 2 oxygens going in. Oh, only 1 oxygen coming out. This is not balanced, so we're going to have to work on it. Okay, so let's do this. Can we just add a subscript? That works, right? 2 hydrogens, 2 oxygens, 2 hydrogens, 2 oxygens. It balances, but no. You cannot change the subscripts. We're only working with coefficients. Only with coefficients. Okay, so if we change the coefficient, what do we have here? Right? We've changed the coefficient. So we have 2 hydrogen going in. Oh, but we got 4 coming out. That doesn't work either. So now we're going to have to change another coefficient. Oh, now we're going to add over here. So we've got 4 hydrogens going in. 1, 2, 3, 4. We got 4 hydrogens coming out. 1, 2, 3, 4. 2 oxygens going in. 1, 2. 2 oxygens coming out. So we balance. So it's the coefficients that we change until we get a balanced equation. We're working with the coefficients in order to get a balanced equation. Now you can try these on your own. Remember, you're counting the atoms on each side. Okay, and the only thing you can change, that's why these lines are here, the only thing you can change is the coefficient. So try these 4 on your own, and we'll check those in class to see how well you did. Remember, only the coefficients can change. You cannot change a subscript.